Hello and welcome to another interesting conversation with interesting people from software development. I'm Alex Bolboaca. I'm coming to you from the Mosaic Work Studios, and today my guest is an engineer, architect, AWS serverless hero at the Lego Group, which will be a very interesting conversation for me. We have a lot of things in common. I'm interested in serverless and I'm interested in Lego, so why not? Welcome, Sheen Brisals.
Thank you so much, Alexandra. Thanks for having me. Pleased to be here.
So we met through a happenstance because we were looking for speakers for ITCAM conference on architecture, and serverless is an interesting topic. But before we go there, I would like to ask you a few questions about how you started in software development. What made you go in and pick this career over others?
Yeah, interesting. So that is kind of going back many years. So I started my career in the IT industry early 90s. So when I finished my engineering degree, I wasn't sure where to go next, whether to proceed with the MBA on the management side or go with the master's in engineering. So around that time, I decided to pursue the computers or the software side of things. So then I did a master's in computers, and that's what it changed. I mean, as you can imagine, those days, no one, used to born with, mobile device or anything. So even, seeing a computer itself used to be a luxury those days. So that's how I ended up in software. So when I finished my master's, I thought, okay, this is a good field to be here. So that's how I started my engineering career. So initial part, I was mixing my engineering with the software, and then I moved on to full stream commercial software engineering side. Yeah.
And what was your first programming language or your first programming languages that you worked with?
Um, Quite a few, but I spent probably 4 or 5 years doing a C language, but I was also exposed to doing Fortran and COBOL up to some extent, and things like DBase 3, DBase 4, probably no one heard of. So the early days of database tooling side of things. So yeah, so commercially these things I used my early days.
Okay. And then at some point I don't know exactly what's the timeline here. Did you get first into architecture and then at Lego, or first at Lego and then into architecture? What was your...
No, so architecture part was there with me from the beginning. So early days, I was attached to the whole software development life cycle. So if you go back in the early 90s, the structured systems analysis and design, SSADM was popular. And then came the OOAO, object-oriented analysis and design. So I switched over to that and also to C++. And then I got into object modeling technique, OMT, then, of course, the UML, the unified modeling stuff. So as part of this progression, I was also getting exposed to the different architectural elements that were there. So if you think of the three-tier client-server architecture, which was once very popular, and I was part of that. And then when I moved to doing programming in Java, that exposed to distributed computing, and slowly the sort of the web server, that sort of evolution, and then to web services. So that's how I gradually moved on. And around that time when I was working with web services, the whole term like microservices was kind of, getting heard of or popular. So then I started to explore microservices, and that then brought me to cloud, and how the cloud evolution then helps out the customers, and that's how I ended up doing more on AWS and serverless. And then I kind of, predominantly started to work with cloud architectures and these days, especially in serverless.
We have a lot of customers who are so usually developers who moved to architecture, and the usual move to software architect is you are a good developer and somebody tells you, okay, so now you are an architect. And they
Yeah.
often have challenges with this change, with this sudden switch. So
Mhm.
I'm curious whenever I hear about people like you who went through various stages and got into architecture, what was the most difficult part for the switch to being an architect?
Um, so I'll explain that, but before I get there, it can be a challenge for someone as a software engineer focusing purely on programming. So typically in industry, there are situations where if you're a software engineer, you are given a task with all the details to do. So all you do is in your, the programming language, you just do the coding part and you don't know anything about anything. Okay. But on the other side, there are teams and companies where they expose engineers to beyond programming. Okay, so in that part of the setup, engineers become more aware of the architecture side of things. Now, if someone is from the programming or engineering coming straight on to architecture, the challenges could be having the visualization of the entirety, because often you don't have that the overall picture of what you're building because you're just focusing on certain elements, right? So that can be a challenge, and changing that your mindset to think that way, and also then think of all the elements that are part of the architecture and make sure everything then connected together and taken care of. So those are of the initial the struggles. Then of course when it comes to sort of production level, you need to understand all the scalability issues and how can I make it resilient, highly available to everyone, all the disaster recovery aspects of a good architecture and implementation. So all these things come together. But having that sort of the overall understanding and the mindset, I think that's probably the most challenging thing for someone jumping from programming onto architecture switch.
Okay. Um, and you work at a Lego Group, and this is interesting because I don't associate the Lego Group with technology except Mindstorms, but it seems that everything is serverless there based on the articles that I read, or a lot of things have gotten into serverless. So, what do you do at the Lego Group? As much as you
Um,
can share, of course.
no, no, that's very interesting because I usually hear the same thing with the many people I meet at conferences, because they always say that, oh, Lego, you doing, serverless, you do this, etc. But that's always there. So listen, any big corporate, Lego or other companies, they have different departments, different implementations, and the evolution of the change happens for different places. So I'm related to the Lego.com and the e-commerce part of the business. So of course in the Lego group there are a number of different teams focusing on different aspects of the business. So when I talk usually about the serverless and what we did is basically around the Lego.com domain and what we do as part of the e-commerce business side. So for us, this happened when we were thinking of migrating from the legacy platform, which was on Java, running on the typical application server setup and things like that. So as I mentioned, the microservices, the aspect in me. So when I was looking for a new challenge or a new role, they were also thinking of moving towards microservices-based architecture and things. So there was no cloud or serverless thinking at that point. But later on, as I joined and things evolved, and we looked at a number of options to move to cloud, and the serverless looked very appealing. And then spoke to a few people who were at that time doing serverless, and that's what convinced us to, move towards serverless. And then a few other teams also started to work on serverless, but I wouldn't say everything is serverless. There are number of on-prem and containers and Kubernetes and various other implementations all around. Yeah.
Yeah, I've been reading through your articles you publish on Medium. I think it's the Lego Group account, and there are a bunch of articles there about serverless, and I found them very interesting because I've also started managing infrastructure for MosaicWorks, and so serverless is interesting because it allows us to have lower maintenance and less costs, particularly for those things that are not as commonly used, those things that we use from time to time or a few times a day that don't require a server to run a long time. What was the use case in your case? What made serverless attractive?
That the scenario or the use case you mentioned, that is the typical one you hear when we talk about serverless, okay? Because you don't have anything. But in our case, one of the biggest the motivators for us was to move away from managing any of the infrastructure side of things, especially to do with because coming from the on-prem setup and knowing the pain or the struggle getting every release out and making sure everything is up and running, and the hours you spend doing all these things once in few weeks or month or whatever. So that was one of the main motivators for us. So we were looking for an approach or a solution where we can be 100% hands-free. So that's one of the main reasons serverless was an attraction to us. And for us, because as you can imagine, running an e-commerce shop and having all the services behind the scenes serverless doesn't mean that it's only invoked once in a while and going quiet rest of the time. For us, the traffic comes all the time, and often when we have promotions and special occasions, it's very spiky traffic, and all handled by serverless. So that's the other thing. Then we realize, okay, so with serverless, in such situations, we don't need to worry too much about provisioning the capacity or setting up the the scaling aspects and things like that. So that's how kind of slowly we started to get into serverless, and of course that the speed of development then we noticed, because engineers can just focus on getting the features done with the the serverless setup. So that again proved that is so one of the nicest things to have with serverless. Yeah.
However, on the other side, one thing that I'm paying attention to is there's vendor lock-in, because you start with AWS, you can pretty much get stuck with them, and be very hard to move away, which may be a problem. We don't know yet. And I think in your case, another issue that might be interesting to discuss is the time it takes for functions to start, right? There's a cold start there.
Yeah.
Were there any other challenges that you figured?
So two or three things you touched upon. So let's start with the cold start. So it was a concern. And if you've been watching the trend, AWS as well as the other providers, cloud providers, all they've been improving the the cold start time frame. So if you think a year or two back, everyone used to have some kind of mechanism to have certain instances of Lambda functions warm. So that used to be there. But then if you take AWS, they improved the cold start, the performance vastly. And also they have, options to keep certain, functions warm, like with the provision concurrency setting. And when we first compared the performance of Lambda functions written in Node.js versus Go and one or two other things, we didn't find alarming or concerning issues with the performance. So we did notice that, of course, when you have a lambda function starting up cold, yes, there is a bit of things. But thing is, if you have steady traffic flowing through, touching upon the core functions you have, you always going to have few instances warm anyway. Okay, so that's probably the reason why it didn't really affect us, early days when we start. Of course, when you have the spiky traffic, there are situations, you have a bunch of lambda functions starting cold, but you have other mechanisms to, work with your provider or have some sort of, warming up options set up to keep that going. Now, so it's not a, it's a major concern for us, especially on that front. Now, if you come back to the vendor locking, that is a very common topic talked of across organizations, industry. Many people ask, "Oh, you're not worried about vendor locking and things like that?" Yes, yes, it can be a worry. But thing is, recently I was reading a Twitter post where someone mentioned that if you're working with a cloud provider, basically your platform is there, your infrastructure is there. Don't consider that as a vendor. That's more like a partner to you. The vendor is somebody else who providing a simple software something. So because your business entirely relies on this particular provider, so that means more like a partner. So you have that sort of mindset. And the other thing is there are ways you can build something vendor neutral and etc etc. But thing is, you need to choose between, again, someone nicely put on the tweet that you need to decide between whether you need the complexity in making everything perfect, or you're looking at the simplistic velocity that you want to have in this competitive world. So that is the choice. Now there are applications, there are domains where you need to make vendor agnostic or neutral based on certain things. But otherwise, you need to make a balance and decision which is going to be beneficial for the business. Whether you want to add in all the complexity and delay getting to the market, or do you want to trust something already proven in the industry and gain the velocity and move fast.
Okay. Another question that I think comes often, in particular after the experience with microservices, is how do we figure out how to split a large thing like an e-commerce thing into small pieces, whether they are microservices or serverless services, fundamentally, serverless functions. Uh, and there's no great answer for this. So how did you proceed here?
Yeah, that's a very, very good question. As you mentioned, there is no magic formula that fits everyone. Okay. I know there are books written about breaking a monolith into microservices. There are books on microservices and things like. So if you follow those books, what they usually touch upon is the domain-driven design. Okay, so the talk about the domains, they they bring a lot of value when you look at your monolithic application. Now, with that mindset, if you look, you can somehow figure out, okay, so here are a bunch of things, they will form into these domains. Okay. So that concept can be then expanded to, break that into bigger pieces than into smaller pieces. I mean, it's easier to say, but there are applications where this can be really challenging, especially applications have been built for the number of years, added on with so many customizations and things like that. But still, if you think of these sort of the grouping of functionalities or your business domain mapping, then at least you will get a starting point. And once you have a starting point, from there you can slowly, progress further, taking them apart. Now, I usually, I mean, I have written about that as well, and I have gone beyond the microservices, setup. That's good because when you start something, yes, you need to have these setups. Like if you think of a customer domain or a product domain or something like that, that's good as a starting point. But then when it comes to serverless, the advantage you get with the serverless technology is that you can go down deeper level and optimize every single bit. The granularity of the control you get, you can optimize one function from the other function. You can optimize one table from the other and the queue from the other. So that means the technology is offering more than what you used to get from your containerized application setup or your on-prem setup. So that way, we can even make use of the technology to break these microservice blocks further down and to simple services, because now we have the technology that gives you the support. And especially when you bring in the APIs or the event driven approach, that basically gives you that extra, the momentum to go even further beyond the typical microservices, mindset and the development process.
And I'd like to touch in a moment on event-driven architecture, because I think this is one of the common changes related to microservices and serverless. But before that, I think there's interesting to discuss about how much of this splitting into lambdas or into services comes from an architect and how much comes from the development. Is there a continuous process, or is that something that you establish in the beginning and then kind of iterate on it? How does it happen?
So I'm a great fan of iterative development. I always say that start something small and evolve from there. Okay. So in that respect, if we have, I mean, we talked about the becoming a programming from a programmer to become an architect. The benefit of becoming an architect from your engineering or programming background is that you would be able to connect when you architect a particular application or a feature or a service. You would be able to connect with the engineering aspect of that architecture as well. So that really helps when it comes to serverless, because even when you start with a high level view, and then slowly when you take the work to the development streams, you would be able to communicate and explain them, this is how. And depending on the knowledge of the team that you work with, you can decide to stay at a high level, or you can even go down to the deeper lambda function level. Typically, in my experience, as I mentioned, with regards to the experience of the team, I usually stay at a high level. I don't need to go even down to the individual lambda functions level. So if I say that, okay, so here is an API endpoint that is backed by a lambda function, for example, and that talks to something else, then the engineers with a bit of experience will be able to, figure out the remaining pieces in there. But there are cases where we have the number of services they need to communicate in an async fashion, for example. Then it's important to define those sort of, the boundaries or the exchanging data contracts and things like that. So to answer your question, it actually depends. So sometimes, yes, it's beneficial to go down deeper. Say, for example, if I go back 2 or 3 years ago when we started serverless, we used to bring out solution design specifications. So those days, the solution design specification used to have the architectural diagram. So we used to go down as much detail as possible, because the team was new, and it was beneficial for engineers to have more clarity. But as the experience the grew, we didn't need to go that level deep. So we are able to stand up at a higher level, and also engineers take part in the architectural aspects of this. So that's another benefit. So as they share, as they contribute more towards the architecture, your job becomes easier, right? So that again is a healthy team environment to have. Yeah.
So before we go back to the higher level, let me ask you a question about the lower level, which is, and I know you wrote an article on this on Medium, which I found very interesting. Very small lambdas with one responsibility, or bigger lambdas with multiple responsibilities? What's the right choice?
It depends. So I think one of the early blogs I wrote, that one I remember, because that time that the one of the use case I think I mentioned, it was a real case. We had to do a bunch of validations and things. The question was, should we do in a single Lambda function or should we have multiple Lambda functions? Again, it changed again the perception, because I remember one of the comments I received at that point was someone said I would go with one big Lambda function because the cost was a factor. Because you remember in AWS they used to be charged every 100 millisecond and that way. So the argument was that if the function was going to be within the basic 100 millisecond limit, then there is a benefit. But now that's gone. So it's now per millisecond kind of down to that building more granular stuff. So and also the performance aspect also changed. So now if you ask me, I would say if it's possible, try to be a single responsibility, follow that pattern and have the Lambda functions smaller rather than combining bunch of things together. But back in those days, it was really a attractive thing to have kind of the big Lambda function doing multiple things due to various reasons.
I noticed when I worked with companies who built and started to build microservices-based architecture, one of the very common mistakes was creating a mess because microservices were calling each other directly, and then they ended up basically in dependency hell. When you change a microservice that's very low in the hierarchy, you need to change everything. It kind of blows up and it slows you down instead of allowing you to speed up. And I think this seems like something that is maybe a problem also for Lambdas and for serverless as well. The usual answer to this, I think, it's event-based architecture and discussing in messages and events instead of discussing directly. But what do you think?
Now that is a absolutely true case. So situations where you have number of microservices and they have the communication pattern, APIs, or these things can completely go wrong when things change upstream, downstream, everywhere. Now, as I briefly mentioned earlier on, whether we have a bigger microservice or smaller services, it's important to identify the boundaries and then establish those sort of exit entry points and make sure that those things are properly documented or published. So with the event driven, so one of the ways we do is every event, so we have a sort of a standard event structure so that we try to follow for all the custom events, and that helps. So all the events, different events will have a kind of similar pattern. There, the data payload will be different, but the common structure will be the same. And then if we have some kind of registry, so with if you talk about AWS Event Bridge, there is a schema registry that you can publish, and you can base the schema based on open APIs and the standards. So that really helps. And many of the services in the what engineers do is they keep this sort of schema contract as part of the GitHub repository itself. So that becomes easier for engineers to refer and understand what is the event that we are consuming or sending out. Now there are a number of ways people try and try to overcome this the issue of this mess around number of services, but I don't think there is any clean solution. So there is something that we need to put in place in order to make this happen. Again, for example, a particular service can send an event to central bus, for example, but the consuming service may be taking a transformed version of that particular event. Okay, so it may not be receiving the same event. So at the receiving end, the schema has already changed. Okay, so if you think back the olden days when we have a SOA or enterprise integration, we used to have these sort of adapters and connectors where you used to have the XSLT transformations, doing all the XML, transformation logic and things. So there are ways we can limit the complexity, but obviously, as we break things down into smaller pieces, the complexity will be always be there in that magnitude. But how we try and manage is how what makes us to more comfortable than getting into the to the mess.
Yeah, and I think it's always a trade-off from what I've noticed, and that's what I try to teach people when I work with them. Think about the trade-offs.
Yeah.
You move an event through a bus and then it goes to somebody else. That's fine in some cases, but in other cases, perhaps you need more performance or you need faster response, and then you need to call directly. But be very careful where you are doing this and where you are not, because otherwise it can get into a mess. Yeah.
Exactly. That's a very valid point, because if you have APIs and if you make a synchronous API call, you're making that for a purpose, because you want to be performant. That is a sync operation. Maybe a customer is waiting, behind that particular, the chain of calls. So you need to, get back to the customer, also the user, quickly. Whereas you have a typical scenario where you're receiving a batch of things. So that is going to take time. So you basically decouple from your API invocation and let the background event stream part take care of the rest. And yeah, absolutely.
And this leads me to another challenge that I've seen many teams face with microservices more than serverless, because I work more with teams using microservices, but I imagine it's similar. And that is being able to follow if something goes wrong, figuring out what went wrong and where. And here some of the common advice is to use some kind of request identifier that you pass on, and you can see the request in your logs from one end to the other, particularly when you have events and so on. But what other things have you faced?
No, I think that is one of the biggest challenges teams face when they start using serverless. And things are getting better. I mean, there are tools, obviously, with the cloud providers like AWS has X-Ray, and they keep on enhancing that. And also, there are a number of tools out there. There are many tools, in particular, good fit for serverless development environment. So, like you mentioned, there are people use that of typical trace IDs and things that flow from all the way from the start to end. So that kind of gives a bit more of help to trace or debug through the problems. I mean, I know these tools are not very kind of cost friendly. So if you are a smaller team starting serverless, that can be a challenge if you don't want to spend too much money on monitoring or different tools. But the other thing that helps, what I was seeing engineering teams and we also do, is have some sort of a structured logging in place. So when you start your serverless development, have something in place to make sure, okay, how the logging is going to be, what am I going to put in the log, and how can I then, if I go to if I go to my log repository and do a search and things, it should be able to bring back the relevant details that would help me to at least debug through, trace through, and hopefully identify and fix the problem. So these are sort of the best practices that we can follow to have a better approach that will give us that sort of visibility. And of course, there are tools, but they are improving, but still can be a challenge. I can't deny that, but things improved a lot recently. Yeah.
Another thing that I'm interested in is how you deal with evolution of features. So let's say you get a new feature that you need to implement, and there's always a choice whether you change an existing Lambda or you create a new Lambda, you change an existing API or you add to a new API. And these are always come with trade-offs. Some of them require more change, some of them require less change. And I'm curious about your experience here.
Yeah, that's again a very good point, actually. That is very common these days. Yeah, typically, if you go back to the olden days, we would kind of, refactor the existing stuff and spend time trying to fix everything. But again, with the freedom of, with the services and the cloud we have, we can decide whether to develop something in parallel or to mess around with the existing one. Often you will find, depending on the use case, of course, that developing something in parallel and switching over may be more beneficial and less risky than trying to fix the existing one. The same with the APIs. I mean, most APIs these days come with versioning. So if you are, doing something new, then obviously it's a new version development. And also, I mean, we started to call certain Lambda functions or serverless services legacy services, even though it's just a few years old. Already the legacy term is now part of the serverless development mindset. So we have the approach we usually have is completely set up a new service with the new needs or improved resources or whatever, and then slowly switch the old one to use the new one. So that's been our approach, and I see the benefit there. I mean, like I mentioned, it takes away so much of the complexity and the difficulties, and you have more freedom and the free road. You can always bring in new services and make it more better in a way. Yeah.
This reminds me, I enjoy working with legacy code in general. It's one of my peculiarities. I know many people don't, but I actually like working and. But I know usually it's very complex and it's time consuming to start from an existing code base and fiddling with it until you get it to a nice place where you can actually add features. And one of the most common techniques actually that I advise people to use is to write the feature completely separately, even in monoliths, if there is some duplication, it's usually easier to do that than to refactor, and unless you have a lot of skills and a lot of tools at your disposal. Okay, so if we go back to let's say the event-driven approach. I think this is one of the challenges for serverless thing because you need to think differently. You need to think into smaller pieces that interact indirectly, not directly.
Yeah.
And how do you architect this? You mentioned domain-driven design as one of the solutions, but do you also use something else to help you with when defining events? Do you also use other techniques for dealing with this or for teaching people who are new at event-driven?
Not necessarily new techniques per se. It's more of creating that awareness. Say, for example, I can tell you a recent example. So we currently are working with a team. They're building a new set of APIs to, work with the customer loyalty side of things. Now, an engineer was looking at, the registration API setting. And behind the scenes, there is a vendor, a SaaS platform that we interact with. So the typical engineering mindset was like, okay, here is our API, receive the request, have a Lambda function, goes out to the third-party vendor, get the registration website. So I asked him, so how can we operate if the vendor platform is not there? Because knowing that they have their downtime as part of the SLA, how can we satisfy the customer? Do we really need them to be there? And that sort of kicked off the thinking with the engineer. Okay, so how can I then decouple this part? And I said, okay, so in order to accept a registration to give back a response, we don't need the vendor platform, okay, because we can generate the ID or detail or whatever. So then the question is, so what do we do once we think? I said, yes, put the event out, and let somebody else take care of it. So that's how that part of the architecture changed. So what happens now is that receives the request, satisfies the request, but behind the scenes, there is an event going out to somewhere, to the bus or queue or somewhere that will be kind of taken care. So here, this is an example of how that mindset can be developed. So when this engineer now brings up as a service development, it's going to be that this particular API that performs the initial part is going to be a one smaller microservice, serverless service, whereas behind the scenes, the decoupled one that takes care of using a queue or persisting in a store or taking care of the availability of the third-party platform and doing all sorts of things is going to be completely in a separate service itself. And in addition to this, we need to have auditing in place. So every request and response come to this API should be kept somewhere. So again, events help. So this service just sends an event. Okay, I received this request. I'm sending this response. Somebody else will take care. So that part will be a different service. So if we kind of talk to engineers in this sort of terms and explain, and slowly that sort of that mindset will slowly come in. Otherwise, it can be really difficult, especially if you come from the all-encompassing monolith development framework. Then for you, everything looks one thing. So yeah, there are challenges, but once you get that idea, then they will it makes things a bit easier. So as part of this, you can bring in the different architectural element. You can talk about the domain-driven design up to some extent, but we are going deeper than the typical domain level we stand. So that's where I often call the set piece development, and just focusing on the parts and then bring all the parts together in kind of one feature or a service there.
And one thing that I'm thinking of is that performance can be a factor here, right? Because you mentioned scalability, but part of scalability is also to ensure performance for the most heavy traffic areas and so on. So how do you deal with those issues? How do you find the performance bottlenecks in such systems, in serverless? And
yeah, so if you're still thinking staying with the event driven and performance, like I mentioned briefly earlier, if you're developing an API that fronts a user or a customer request, then you need to think of making it as quickly as possible. So if that service requires synchronous API call, just do it and get back the response and serve the customer. Whereas there are situations where you can really decouple or you can really make async, for example. So those situations, you have a bit more freedom to play with. You're not kind of, putting the performance of your platform or a service in trouble. Okay, so you need to identify such scenarios. But when it comes to critical, performance functions or APIs, obviously we need to focus on optimizing or tuning them accordingly. So that again, like you mentioned, it can be a trade-off. In certain cases, you may need to provision more resources. For example, if you're talking about Lambda functions, you may be provisioning more memory than it really requires because you are gaining a bit more performance. So you need to kind of do that balance right. Whereas in the background processing Lambda functions, you can be a bit strict on what you give and how much you provision.
Okay. Another thing that comes, and I've seen it mentioned related to serverless, and I think it's not correct, is that typically you don't do serverless with state when you have state. And obviously you cannot store state in a Lambda because it will go away, but there is state stored, and particularly in your case, since you have an e-commerce kind of application, you have state somewhere. So how do you deal with state?
Yeah, so that's a very common question of people ask, what do we do? Um, there are a number of ways. There are different ways we can do. The one option is to use some sort of a cache, elastic cache service or something. And if you take, for example, AWS, and if your Lambda functions are within a custom VPC, then you can access to the Redis cache or something that you can keep use. The other option is to use some kind of a serverless database like a DynamoDB. That is a very common pattern people use it and just take it away. And when it comes to attributes or certain parameters, there are ways to keep in, say, in AWS, or something called parameter store that you can keep. And the most common thing I see is the DynamoDB, because its performance is is milliseconds, and it's really something that many people use to maintain the state. Um, Lambda functions can be used if you're not too worried about just keeping some sort of temporary values in Lambda memory, or it's a Lambda's local storage. And if you know that certain Lambda functions are going to be kept warm, and container is going to be there, that's okay. But otherwise, the other options are there. But once you get used to that, I think it works well. It suits well. So yeah.
And I've noticed.
One other thing. So you started off with talking about the statefulness. So, and also the thing is, like, typically when we deploy serverless services, and if you have that sort of service creates and maintains certain resources, obviously they will get recreated and things. So, but in serverless, sometimes you need to maintain certain resources. Say, for example, certain S3 buckets or DynamoDB tables and things like that. Should be there all the time. You can't afford to bring them down and recreate. So what we usually call in the serverless world is sort of a stateful resources, for example. So those resources will get created separately and not attached to the services. So there are ways people maintain these things that are supposed to be there, irrespective of what happens to your service deployment. Yeah.
Yeah, and this of course leads to the challenges of using distributed transactions or eventual consistency and things like that. And do you have, I'm trying to think if in your case there would be any issue with eventual consistency. I know there are some some domains where eventual consistency is a problem, and then you need to use transactional behavior. But what is
Yeah.
your case?
No, we don't have too many of those as an issue. But again, there are options available that we can make use of. Um, so different data sources, S3 or DynamoDB, always have the option to always have the consistent read and things like that. I think even S3 recently introduced. So that is there, and with the Dynamo, there is the transactional read write option as well. But thing is, you need to when it comes to these services, you need to also balance the cost implications, because obviously the cost structure is different. It's not same for your eventual consistency, or the strong one, or the transactional. Obviously, the price varies. So that's where you need to think of, okay, for this particular service or a feature or a requirement, what is the best, the optimum need I have? Should I have a strong consistency or a transactional one, or is it okay to just have the eventual one? So there are always that trademarks. So that's the other side. Like I mentioned earlier, though we have the option to go granular and tune everything, we also now have these problems because they've gone too granular. So you need to now have your own thinking cap and to decide what's the best one, balancing the performance, cost, and other aspects.
So we mentioned a bunch of cross-functional concerns like scalability and performance, but I think there are and cost, which becomes
Yeah.
a very important cross-functional concern for any cloud-based development. But now there are two more that I think are worth discussing, and one of them is security and the other resiliency. Now, security is a huge topic, of course, but one deep problem, one common problem I have with AWS is that it's very difficult to figure out the minimum level of permissions to give to a specific service or to, and I don't know if you figured out something around this and in general, how are you dealing with security?
Um, yeah, so security, obviously, it's a huge topic and also a very important topic. And I know when we start serverless, it's very easy to get things wrong when it comes to security, because if I'm new to serverless, I don't have the overall, the understanding of everything and how do I do. So I try to follow the simple approach, and obviously that's probably the wrong approach. Okay. Now, there are many ways the security awareness and the the implementation comes together in serverless. There are ways. So we have this sort of the principle of least privilege, for example. So that means, so unless a particular resource requires a permission to do a certain thing, it doesn't need to have anything, right? So that's sort of the mindset. I mean, to be honest, not many engineers know these sort of the simple things, but they slowly learn from others. So these principles are there, and how we make use of is part of the experienced engineers or the architects, whoever is looking after all that. The engineers is their responsibility as well. I mean, it's not just about the functions invoking something else. Even when it comes to the visibility of data that you keep in a particular data store, okay, who can view what data is kept and who can view, and always, because there are a few things that any commercial organization these days will go through: data privacy, GDPR, PII data. All these things are important and the real stuff that we need to take care, right? So that's when what data we keep and how we keep all the the encryption mechanisms and access to the data storage and redacting the data that you don't want to keep and everything. All these things matter. So, and then when we build APIs, that needs to be thought through as well. What sort of mechanism we have to protect the APIs? Of course, the cloud providers have certain things to avoid, the flooding attack and things like that. But how we secure our API is up to us, right? So understanding those the different options and understanding the benefit of the different options are really crucial. Say, for example, whether you use the OAuth based authentication mechanism, or in AWS what they call the SIG v4, the signature v4 mechanism, or even internally people use the API key based approach. So identifying and choosing the right one, it's important. But again, as I mentioned, when you start new, you don't have the visibility of what you obviously look for a simple option to get going. That's fine, as long as you kind of, once you understood, you change that and to make it better. Yeah.
Yeah, I've learned that there is for people watching us or listening to us, there is a tool in AWS, permission checker or tester, that allows you to write some permissions and check whether they work or not. And this is helpful, but it's still very, very complex because the granular level of permissions in AWS is very, very
Yeah.
there are hundreds of thousands of permissions that you can add, and it's quite easy to make mistakes there. So
Exactly.
it's still,
Exactly.
yeah.
I mean, yeah, AWS and other providers, they have a bunch of tools that can, help us. One other thing it'd be useful to highlight here is if you are building something and going through your architecture is to have the threat modeling in place, or at least think about the threat modeling. Because I recently wrote a blog post on why even serverless requires a threat modeling. It's because not because of the technology behind this, mitigating the threats and things. It's because that process brings out the questions and the needs and the requirements why we need. So, say like I mentioned, when we store data, that's when engineers get the question. Okay, who can view the data, what data is stored, how long do we need to keep the data, is it compliant with card industry standard or this and that. So those questions will come out if we had a phase to go through the security aspect of a particular service. So there is no sort of one solution or a quick fix solution. It's kind of a process and understanding and the knowledge that comes together, and that's how these sort of things get better.
And finally, a very important topic, which is resilience, which you mentioned. Chaos engineering is one approach here, which is I notice whenever I talk about it with people who are not used with it that they find it extremely weird and extremely counterintuitive. And so I'm curious, how do you do resilience and how much are engineers involved in this?
So again, chaos engineering is a very attractive topic, but when you start thinking or doing something, that's where everyone gets a bit disappointed, because there isn't much of a support, and also not many teams or people see the real benefit. There are tools now becoming available. I think AWS released a fault injector and other things that would help. And also, I know a few of my sort of industry friends. They are specialists in chaos engineering and the side of things. The challenge with serverless is when it comes to resiliency and things, not all services can be easily spread around. Say, for example, if you're thinking of a typical disaster recovery setup, you can easily set up one set of stack in one particular region and replicate into other thing. Easily you switch over, everything is going. When it comes to serverless, there are a number of managed other services behind the scenes. So we talked about DynamoDB. So there is a service called Cognito, which maintains the users and authentication, things like that. So DynamoDB, yes, you have global tables, and even though that's expensive because you're paying double or more, but when it comes to Cognito, that is not something that you can easily distribute across different regions and have a seamless switchover from one region to other. So these challenges are there when it comes to serverless, and especially when it comes to event-driven computing as well. So that's again another trade-off that we need to look into, and also see how it can be made better for the serverless community as they adopt serverless. Back to so we don't use sort of chaos engineering at full scale. But the simple things like like I talked about, the raising the awareness. So we have engineers, our engineers go through security, secure code warrior courses and things like that to raise the awareness, to make sure that okay, how can I detect a certain part of the code which can be prone to threats, or how can I check an incoming payload for issues and things like that. But this is a topic that I think will gain more. But so far, I know that Netflix they talk a lot about chaos engineering and doing in a big scale, but not something that has filtered down to every simple team or organization. Yeah.
Yeah. Okay, so we used to close these interviews with 6 questions these are open-ended questions and they are non-mandatory, so you can skip if
Okay,
you want
that's
to.
good.
But it's more to understand you better as a developer, as a person. That's kind of and to give a nice end to our conversation.
Mhm.
First question, is there a book that you like and would recommend? It doesn't have to be serverless, it doesn't even have to be technical, but
Oh, there are many books. Um, there are many books. One, I'll mention one or two, not technical or anything. So I liked, what is it called? Factfulness. There's a book called Factfulness. I don't know, they were kind of, pictured the real situation and how the world global level stats and things add up. And I think the author was a doctor, and towards only when I moved towards the end of the book, I realized he passed away, and it was kind of a book I remember. I think one will do, right? So
yeah,
there,
sure.
there are quite a few, So.
Yeah, I've heard about it. I haven't read it yet, but I've heard about it, and my colleague is trying to add it to the video. But I know it is a very nice, very interesting book about this. Yeah, working with numbers and with facts and with instead of getting
Yeah,
fooled by opinions.
yeah. I mean, I usually read quite a few books and still have two or three in my backlog to read. Uh,
Yeah,
but these days, due to working from home, I don't have my commute time. That's when I usually used to read books.
yeah, commutes were good for reading books. Okay, so my colleague will add it to the video in a few moments, but we can move to the next question.
Mhm.
Is there a category of books you don't read too much, and why?
Yes, there is. I don't read fiction novels because there's nothing wrong there, but for me, I can't connect with that. I know I'm reading a fiction, so that means I know kind of all imaginary and stuff, no facts. So maybe that's why.
Okay. Uh, is there a topic that you think is not discussed enough in the IT industry or in communities around IT?
Um, that's a hard question. Uh, maybe one thing, which maybe because I've been through different era of software engineering and things. So now the more engineering capability is not often talked about because the way many teams operate is engineers are spoon fed with all the details in the ticket or etc etc. So I would something should be talked in the community to encourage that the sort of engineering mindset to bring out more thinking and more creativity. So maybe something that we should start talk about at conferences.
Yeah, sounds right. Is there a topic that you think is discussed too much in the industry or in communities?
Yeah, there are a few topics that will get me into trouble.
As I said, you can skip
But
the question.
I will say something. If not talked quite a lot, but argued a lot. There is this argument about REST versus GraphQL. Okay, that passionate both sides. There's deep argument, but my take is please don't. If you understand the evolution of software and software engineering industry, then you will know the reason why we have REST APIs, why we have SOAP web services, and why we have GraphQL and what they try to resolve. So that understanding is needed, and that will eliminate these sort of nonsense, unnecessary arguments and debates.
Okay, yeah, that sounds right. It's the right tool for the job, right? General principle. Okay, fifth question. What would be your ultimate career achievement? That's something that if you do, you would think about retiring, not necessarily because you have the money, but because you think that you've done, you know, the most interesting things.
To do, right? I don't know. Career-wise, I was I was attracted to technology, still attracted to technology. So that's why I've been switching over careers, moving from one technology to other, not necessarily worry about the vertical growth in terms of the different positions I go to. But what I would prefer to do is help smaller teams or smaller teams within a big organization or even a small organization introduce the right technology, if it's serverless or a cloud or anything, and show them the avenues out there for them to grow. Not many teams or companies are aware of the opportunities they can have if they just open up and look beyond. So I would be happy if I'm associated with such teams or organizations and help them to reach, farther grounds or more customers or whatever be their, the goals.
Oh, I see. Yeah. Okay. Last question. What advice would you give to a younger version of yourself?
Younger version. So be open. Don't constrain by something. Be open to explore more. So often engineers have this. I used to have the channel vision. So if I see it, I just see just that. So change that mindset. So that means you can be inclusive. You can bring technology and different ideas and concepts all coming in. So that makes a better engineer, better person. So that probably be my advice. If I start it all over again, that's what I will be, trying to come up with.
Okay, so this was the last question from our ending questionnaire. This was very, very interesting and I hope useful for everybody watching. Before we close, just two more questions. First is there anything that we haven't discussed and that you'd like to share with our audience?
No, I think you kind of covered everything. And I'm glad that I gone past the 6 questions. I was a bit worried when you started. But yeah, it's been a really, great conversation. It's touched upon many things, many types of technology and development patterns and cloud and serverless and everything. So it's been really pleasure.
Thank you. That's the same from my side. I enjoyed this a lot. Where can people find you?
I'm on Twitter, so Sheen Brisals, Twitter. I'm also on LinkedIn, so you can connect me on LinkedIn or Twitter. So I'm not too much on social media, but they can reach me, and also I blog occasionally. So on Medium, Brisals, that's my Medium site. Yeah.
Okay, we'll post these links into the description of the video. So if you are interested in contacting Sheen, you'll have the links there. I like to thank you a lot for this chat. It was it was very interesting. It helped me by solidifying some of the things that I knew, but also seeing what it means for even larger organizations and other different contexts. What it actually means to have this kind of event-driven, serverless, cloud-based architecture. It's quite interesting. So thank you very
Yeah,
much for sharing so many useful insights.
thank you so much. Thank you so much for this opportunity and having me on your show. Yeah, thank you.
Okay, so now it's time to close. As always, we need to pay our dues to the YouTube algorithm. So please like, share, subscribe, comment, talk to other people and tell them that there are some interesting videos on the Think Design Work Smart YouTube channel. Join us for iTakeOn conference because Sheen will be a speaker there, and he's actually talking about serverless and some of the things that you can ask him questions if you are there. And so I'd like to thank you all for your time, for listening, for watching this. Don't hesitate to contact us if you have any ideas for other people we should chat with or other topics that you might be interested in. You can find us on mosaicworks.com. Go to the contact page and you can write to us. Thank you so much, and until next time, remember to think, design, and work smart.